Okay, so the next question that we got on the menu today is asking us, what is the value of arcsine of 1/2? Okay, so arcsine, some of you may have seen arcsine already, but in a different format. So arcsine of 1/2 is equal to sine inverse of 1/2. Now the reason why you might use arcsine instead of saying sine inverse is because sine inverse can sometimes be confused for sine 1/2, but this in to the power of -1. These are not equal. So this is an inverse operation. This is equal to 1 over sine x, or sine 1/2. That's a reciprocal. Okay, so that's why we might use arcsine in the first place, because inverse sine can sometimes be confused with reciprocal sine, especially considering that this case is... so this is confusing because you see stuff like this. Sine squared of x is equal to sine x squared. So because we use this, it can be quite confusing when we see inverse sine this way, because we've seen this. So we use arcsine to be like concrete about it. And let's actually think back to SOHCAHTOA and imagine that we have a right angle triangle. I'll draw one right here with the power of Microsoft Paint. So suppose that we have couple, well, what do we know about this? Well, we know that here we have the hypotenuse, the hype. If we have this as our angle theta, this will be our adjacent ADJ, and this will be our opposite. Now, sine theta, as we know, is for the SOHCAHTOA is opposite and hypotenuse. So sine theta is going to be the opposite divided by the hypotenuse. Okay, and if we wanted to get the theta angle, well, we would use this inverse sign. So if we do this, theta equals sine inverse of op over adjacent, and you know, this is the same as saying arcsine. Op over adjacent. Okay, kind of see how that works. Cool. So let's actually sub in our value here. We have 1/2. So basically we're trying to solve for, I'll write it as arcsine 1/2. So we know that extracting from here, our opposite is equal to 1. Our adjacent, no, not our adjacent, our hypotenuse is equal to 2. Now, the only configuration that this would be possible is if we have an angle of 30 degrees. And you can actually, like, this would be something that you'd really want to type inside of your calculator. But where this comes from is, like, assuming that we have an opposite length of 1, and this length is 2, and we have a right angle here. Consider this, okay? If we just drew a reflected version of it, that would be 1. This would be an equilateral triangle. This would be, that would be 1, and that would be 2. So overall, this would be 2, and this angle overall would be 60. But it would actually be 30 and 30. So I'll write that in red. 30 degrees, 30 degrees. So you can see that if the opposite is 1 and the hypotenuse is 2, it has to be 30 degrees. There's no other option of how this could work out. Okay, so another way that you could write 30 degrees is 30 degrees equals arcsine of 1/2. Another way that you could write this is pi over 6, and that's just the radians version of it. Okay, and gradients, don't worry about too much about gradients. That's fairly rare that you'll ever see it, but yeah, so it really is just taking the arcsine, and you can see that, yep, they got 30 degrees and pi over 6, and that would be precisely what the result is of the arcsine. And hopefully from the diagrams here we can see why this works out, where that comes from, and then we can be happy that we are mathemagicians. Cool. So that's going to be, the above solution is good. It's good.